Hello everyone, welcome to the third part in the series on how to build a Monte Carlo tree search Go playing program. So in this video we'll implement a routine to put the stone on board, and also this would be handling captures. We'll probably implement code in the next video because currently the play function is quite huge, so just to make sure that we don't mess up with things. Okay, so without further ado, let's get started. So I'm continuing with the previous version of the source code, and yeah, in the previous video within the count routine, so just go back to count routine, I forgot to add this line. So if stone is equal to off board, then we want to return. And the reason for this is that if we count the group that hits the board edge, to make sure that we're not going to enter the infinite recursion, we need this condition to return if we just hit the off-board square. So this is quite important. Okay, now that being said, we can keep going with the topic of today's video. So I want to create a new function, board pointer to board structure, and I call it play. Okay, this would be taking the square of a given color, both integer types, and it would return the Boolean value. So true if the move is legal, and false if the move is illegal. Okay, so if board position indexed by the square is not equal to empty, which means that we are about to play onto the square that is already occupied. In this case, we want to return false. Okay, then let's probably do like this. Else if it also might happen that square is equal to board co. In this case, we also want to return false. So return false. Okay, let's make sure this is syntactically correct. Go build and go missing return 116. Yeah, this is okay. Finally we return true. Yeah, okay. So then we want to store the old code, because we might be taking stone back, so we need to store the old code to restore it later. Clear the code, so board.co is equal to empty. If we make a move, if we had a code being set to a given value, we just erase that. Then we literally put the stone on board, so board position indexed by the square is equal to color. Simple and straightforward. Then here we would handle captures, but we will skip this for now, and we want to check for suicide moves. Okay, so I want to say board count and square and the given color, and we store the liberties equals to the length of board liberties, and then restore the board. And if it happens that liberties are equal to 0, which means that the move that we just made is a suicide move, so it would result in a self-capture. In this case, we want to say board position indexed by the square is equal to empty, so we just take back the stone. Okay, and also we want to restore the value of co, so board co equals to old co. Okay, and also want to return false because this was an illegal move. Okay, and otherwise we just do swap the side, so board side equals to board side, 3 minus board side, not size. Okay, and yeah, and eventually we return true. So let's make sure it still compiles. Okay, it does. So let's test all these kind of things. So say I want to do boards dot, I want just to see the return value, so fmt print, and I want to say boards dot play and square 100s play with black. Okay, so we got a move being played. This is good, and the return value is true, so this is okay. Then if I do this again, this should give me a false move. Yeah, true and false. Okay, just want to make it print line. So this time the first move is true, the second move is false, because we play onto exactly the same square that has been already occupied. This has been occupied already. Okay, so next thing to do. So here this is true, and if say we have the value of co, so board.co equals to 100. In this case, it should not put the stone and return false, which is correct. Okay. And finally, last but not least, is copy, paste. So 100s, 102, 121 plus 1, 100s minus 21 plus 1. I'm not quite sure. I want to create a diamond shape. Yeah, I just created a diamond shape. So let's say if I play in here with a different color, it should not be okay. So just 121. So if this is going to be black, it's okay. We can fill own eye. No, this is wrong. 101 like this. So yeah, this is okay. True. But if we do white here, okay. This is not there, and the very last move returned false because we cannot play a suicide move. So when you play here, our stone would have no liberties, hence this is not a legal move. Okay, hopefully this kind of makes sense. Now, if we do put this in here, now this all is legal, but you see, like, our move, our stone has not been captured. So let's implement the logic to capture the group of stones. Okay, so now we go back to in here. So handling captures. Okay, here we need to loop over all of the board squares, and then if we find the stone of the opposite color, or of the color opposite to the side to move, and it has no liberties, then we want to erase all the group. Okay, so for square equals to 0, square is less than board dot size multiplied by board dot size, and square plus plus. Okay, so initializing the stone equals to board dot position indexed by the square. Okay, now if stone is equal to off board, In this case, we just continue. Okay. If stone bitwise ended with the opposite color, so board side, so not 3 minus board side, like this. And if this is greater than 0, okay, so we got a stone of the color opposite to the side to move. We do board count, and we're interested in this very square, and color will be 3 minus color. And then after we restore the board, and here is the condition. So I say if the length of board liberties is equal to 0, essentially meaning there are no liberties left. In this case, all we need to do, we need to loop over I is less than the length of board group. So we need to loop over the elements within the group, over the squares with the group formulator and group, right, plus, and erase those. Okay, so board position indexed by board group indexed by I, and this should be equal to empty. And if I did everything properly, it should now erase the stone, which it does. Okay, so just to make sure we did everything properly, we can try the following. So board play and 100. Yeah, just since I don't have a particular move order, I just do black, white, I just set up the position by setting the value in the board position array. So position and 100 is equal to, say, white, and 101 is white. Let's have a look. Okay, we got white. Okay. Now, board position 99 is going to be black. 102 is going to be black. Now 100 minus 21 is black. 100 minus 20 is black. Just want to make sure. Okay. Now 121. Okay, and 122 would be done via the play routine. So board.play and 122 color black. So these, we just set up the board position regardless of side to move, and here we do play a move, and it should now capture, and indeed it captures the group. Well, obviously, to make sure that the code is bug free, we need to create more complicated positions and make sure that all they are being handled properly. But for this testing, we'll implement GTP interface quite soon, probably even maybe not the next video, but the video after that. And the next video will probably be dealing with co-rule. And then we'll implement GTP GoText protocol interface, and we would be capable of setting up the position from the GUI, all right? And then, after we set the position from the GUI, we need to make sure that the position in the GUI is exactly matches the position in the internal board representation. And also this should be matching with codes. So this is quite important. Okay, so I think this is from my side, guys. Thanks for watching, and I'll see you in the next video. Until then, and cheers.